I wanted to do another Pebble Tales volume for you from Scotland. Unfortunately, the weather really did not cooperate at all. Heavy rain, high winds, that sort of thing. So I'm back home. And here we also have pebbles. It's not a coastline, but we have rivers. And rivers can be just as good as beaches if what you're looking for is interesting rocks. Plus, they've also got loads and loads of little fishes swimming around. See what I mean? Now, the pebbles in a river setting actually come from a slightly different sort of place, in that here we've got this basal layer of boulder clay. This was laid down by glaciers and is full of pebbles from the wider area, which are then being mixed and then eroded by rivers until they are dumped into great big pebble banks like this. It's just an endless array of rocks. I mean, look at that. Is that concrete? Is it natural? Yeah, it's natural. Just a little bit mangled. Might have a look at that one. Oh! Yeah, natural, but not so interesting. In fact, pretty much everything here is peculiar. There's almost nothing here which is immediately familiar to people who just casually look at rocks. There's lots of little crystal lines and so on. There's some dark blue things with strange marks going across them. Is that what I think it is? Okay, that's something different. Oh, I think I know what that is. Yeah, well, hang on to that. Blimey, that's enormous. Okay, right, that's one for the video. Oh, lots of bits of sandstone type things. Trilobites, more trilobites. Yeah, sparkly crystals. I think that little pile should keep us busy enough. Let's have a look at them. Right. Well, there's a big selection here, as you would probably expect, because we're in a very diverse area geologically. It's not like these places like southern England where you have one formation that you can trace across hundreds of miles. Here the formations often fade out after 100 metres, sometimes 200 metres, a kilometre anyway. So they're very small scale things because they were deposited around a volcanic island. And what we've got here in the river, it's a fairly small river, is a mixture of things that have been washed in with the river. So from areas outside the inlier, and there are some things like that, with the things that were in the boulder clay that's forming the basement of the river, and those have of course been transported south from somewhere over that way. And then you've got the local ones which have actually collapsed from the surrounding hillsides and ended up here as well. And it's quite fun just trying to disentangle what you've got, and in some cases it's quite interesting because you don't have any outcrops of them. You're looking at rocks which we don't see anywhere else. So there are definitely some things which have come from further afield. So you see rather lovely ones like this. That is just a grey sandstone, quite a coarse sandstone, slightly pebbly, slightly metamorphosed, but with some rather gorgeous veining going through it from this zigzag white bands. Those are layers of quartz, which is an extremely common vein mineral, probably the most common, and you would expect to get that in sandstone because it's dissolving silicon dioxide from the sand and then redepositing it as crystals within the cracks. So this formed, or these quartz veins formed long ago after the rock was deposited, the sediment was deposited, after it became brittle enough to fracture, so probably after it became a rock. That might have taken 10 million years or so. And then you have some sort of event which crunches up the rock, distorts it, fractures it, and you get the hot water percolating through it to deposit crystals in. And that little event was, in this case, almost certainly going to have been crashing into Scotland. It tends to form all sorts of problems, that sort of event. But yeah, crashing into Scotland, creating this Himalayan scale mountain range that I've mentioned before many times, of which the Welsh hills are the eroded remnants of the foothills after 400 million years of weather. So that's gone through a lot to come here. It's probably not from that far away, maybe 10, 20 miles in that direction. And the glaciers dropped that one nearby, river picked it up, dumped it here. There's quite a lot of that sort of thing though. So there are layers of really quite mangled rock. This is obviously very heavily veined, and the mudstone that it's going through, or fine sandstone, quite hard to tell. Yeah, one of the two, is very hardened as well. So this has almost been cleaved, I think, but you can't tell because it's so crumpled. And that again is going to have come from slightly closer towards the collision zone where we have a bit more metamorphism. And you only have to go 10, 20 miles for that to happen. So this one, well, these rocks made of quartz and silicified sandstones and so on have a very high chance of surviving transport. They're very tough, which is why you get bits of this, but not bits of mud from over there. All right then, we have lots of other bits as well. Oh, just more nice quartz veins in something that's just been cooked so much I can't even identify it. Ooh, some nice crystals in here. Yep, definitely part of a quartz vein, but you can see here, hopefully, that there are hexagonal prism crystals of, well, it's not just quartz, that is very densely coloured quartz. No, I think it's just the surface. It'll be quartz, might be some impurities in there, but yeah, lots of quartz. Most of the rest of these have not been so mangled, so you don't see the veining, but you don't see some weird rocks. Have a look at that. That is a sort of thing that is extremely familiar to anyone who has worked in this area. And yet, outside it, unless you happen to work in a similar area, it's going to be slightly baffling. You've got a very pale grey rock which is very lumpy, it's homogeneous, and it's got these weird grey streaks and blebs all going all the way through it. Some of those have little sort of orange weathering bits in them. But mostly they're just weird lumps of stuff. And in that case, those weird lumps of stuff were originally pumice. So these are pumice-classed lumps of pumice, which is a metastable thing because it's made of glass, which has been then altered by time, pressure, temperature, hot water, and it turns into a variety of clay minerals, effectively. And that's what these green lumps are. They've been squished out of shape. You don't see any of the pumice texture left in that, but that is lumps of pumice in a very fine-grained, silicious volcanic ash. So this will be probably a rhyolite. You'd have to analyse it to make sure, because you can't actually see the crystals in it. But maybe andesite or dacite, something like that. But it's on the silica-rich end of the spectrum. And silica-rich means various things, but viscous is one of the main ones. Lower temperature, higher viscosity, more explosive. You see beds full of this, and you know you've got an explosive eruption. The most viscous ones, technically, are not explosive. They are more like a tube of toothpaste. So pretty much a solid that just gets squeezed out the volcano by pressure and buoyancy, and it forms this column which every now and then collapses into a superheated pyroclastic flow that you don't want to be anywhere near. But in this case, you've got lumps of pumice blasted out everywhere. That's explosive. And there are lots of variations on that, and there are quite a few of these which have been very highly altered. So this was again an extremely silica-rich volcanic ash, and it's been recrystallized almost entirely as quartz. You can see there's veins running all the way through it. There's little sparkly crystals everywhere. It's quite lovely, really. But yeah, this would have been a rhyolite. There was one major eruption in this area that produced a rhyolite, and that was a caldera forming eruption, we are fairly certain. That part's not published, but we've been working on this assumption now for many years because of the a lot of features, the context, the type of sediments that you get. We're pretty certain that this was actually a caldera complex, and this would have been a small part because that eruption is about 100 meters thick. A small part of the eruption that produced the caldera. And when we say a caldera forming, what we mean is that rather than there being a vent with magma coming out the middle like a normal volcano, in a caldera you have a whopping great magma chamber underneath, and then there is a ring fault that forms around the top of it because of planes of weakness. There might be multiple vents around it, and eventually the whole central part collapses like a piston into the magma chamber and splurges out stuff around the edges. And it can be extremely dramatic. So some of the biggest eruptions in history and in prehistory that we know of, things like the big Yellowstone eruptions, are caldera events. So this was a big eruption, not on the scale of Yellowstone, more like Santorini at its worst. And there are lots of other weird ones as well. I mean, you often get green-tinged things with sort of iron weathering on the surface. And you can spend a lot of time looking at these, and it looks like pottery. And you see a bit of that to start with. You might think it's some sort of ancient pottery, but look inside. And you can still see that it's got little flecks of crystals and grey bits in there. It's not pottery. Yeah, if you ever thought that paleontologists were behind the times, some of us haven't actually got past Neolithic, I'm afraid. So, there's a lot more though. There are things like this. And this. Quite colourful, really. Oxidised iron on the surface. On the back, not so much. So this is a genuine sort of surface texture. It's been weathered, but you are seeing the real colours to some extent. And it's a sort of lumpy grey-green rock with crystals in. Oh yes, you get the light reflecting on it, and there are sort of crystals a millimetre or two wide, rectangular things. That'll be plagioclase feldspar. And then you got these little round white things. What on earth's that, I hear you ask? Go on. Well, indeed, very good question. So one can look inside, and you can find that these white bits go all the way through. They are, in fact, slightly different inside. The white is weathered, and there's sort of almost bluey, grey, glassy stuff inside some of these things, which is rather lovely, because those are minerals you don't often see. They form in a very specific way, and they are called, probably, have to analyse them to make sure, but I think they're zeolites. Extremely complex chemical formula, so please don't ask me to tell you what that is, but they're really, really interesting minerals. I mean, zeolites have been implicated as catalysts in all sorts of chemical processes, are very useful today, but they have also been implicated potentially in the origin of life. Zeolites are one of these things that can facilitate chemical reactions. You can get all sorts of things forming or settling inside this extremely porous crystal structure that they have, reacting and then being released. And there has been suggestions that one way of getting complex organic chemistry to happen is inside zeolite crystals. And zeolites form as alteration products of igneous rocks. And what you got here is not crystals so much as masses of crystals that are filling round holes. These holes are gas bubbles. Rather than being a rhyolitic tuff or an ash that settled out as incredibly fine particles onto the seafloor, this was a lava. This was actually erupted as a liquid magma, which then had gas bubbles forming within it as the gases tried to expand and exsolve from the magma, and then the magma freezes and they end up being stuck in place. And then you've got these cavities, which then get infilled by water percolating through it by crystals like zeolites and analcime and calcite sometimes as well, but a range of things. And you can get some quite nice, quite rare crystals because there's so many of them that form in those little bubbles. And we do know roughly what sort of rock this probably was, because somewhere up there on the hillside there is an exposure of pillow basalts. This is where basalt erupts underwater and it cools very quickly, so it's erupted at 800 or 900 degrees, erupts into water, freezes on the surface and basically forms a bubble of a sort of pillow-like mound, which then solidifies, and the next one goes splurge on top and it sort of flumps on top of each other, and you end up with a mound of pillows. Yeah, not the most comfortable pillows in the world. They are, after all, made of 800 degree magma, solidified, but still, they're interesting for geologists. And it tells us things like, up there, the eruption was underwater at that particular time. And the time is, at this point, in the Murchisoni biozone, which is in the waning phase of the really big eruptions in the belt thin layer. So what else we got? We've got some of those. We've got some other mangled ones, which I'm not totally sure if that is local or not. That could have come in from elsewhere. Mass is of calcite crystals. Yeah, the interesting thing about this is it is just so distorted. And it's not so much that there are veins going through this, but the whole thing is basically a vein. This is crunched up rock which has been fractured into pieces, shifted around, turned into an impossible jigsaw puzzle, and then crystals are solidified or are grown around the grains and stuck them together again. It's what you call a fault breccia. So this is from a fault zone. It's not like something like this where you have little fractures and water percolating along it. There may have been little or possibly even no movement at all along those fractures. Along this, well, this whole thing was part of a movement zone. This rock has been crunched up, stuck back together again, and we don't know how far it moved. You'd have to look at it in outcrop and see what the rocks were on either side of the fault. But it's had a bit of a hard time, that one. Still, nice to see. But then the other rock that you get a lot of here is this black stuff, which is slightly sparkly. It's got lots of mica flakes in it. Actually, mica is a really interesting mineral. It forms a sort of glitter-like crystals, or not so much crystals, well, they are crystals, but they're flakes of crystal, which have been washed around as sedimentary particles. And mica is not tough. So you kind of know that if you've got a lot of mica, and if they're big crystals, then it's come quite directly from a source which has been eroding mica-rich rocks. Now, up in the highlands, we were seeing those sort of rocks everywhere. High-grade metamorphics, things like schists and gneisses, are packed full of big mica crystals. And of course, you get metamorphism when you have mountain building, and you can get mountain building when you have mountain building, you also have lots of erosion. So around the coast of Scotland, there are lots of beaches made largely of mica, which is lovely. Sparkly anyway. But here in this volcanic island, we are not near a known mountain range of metamorphic rocks. There are some mountain range remnants, or there were at this time, somewhere over that way, about 20 or 30 miles. But this mica, we're not sure exactly where it came from. But the rest of it is a black siltstone. It's organic rich. It's black because of carbon, which is the remains of, I think, plankton, marine phytoplankton, bits of algae and so on that just settle down from the sea into the sea floor, become part of the sediment and become cooked into the rocks as they're forming. And a lot of this is rather nice stuff. So in this case, there's nothing much obvious on the surface, but we could go back to the Stone Age and try breaking a bit, see if there's anything in there. And what do we have? Drum roll, please. We've got a brachiopod. Oh, and we've got a bit of trilobite. Oh, that's cute. We have a bit of a Patabolus micula, which is the most abundant brachiopod in this area by a factor of about 1 billion. And we also have the corner of a trinucleate trilobite, one of the Cryptolithus species, I think. Yeah, something like that anyway. It's not great. But that immediately tells you that this rock was laid down in the sea, because brachiopods are entirely marine, and trilobites, as far as we know, were entirely marine. And you can kind of confirm the trilobites quite quickly just by walking around, because you see things like this just lying on the surface. Might let you into a little secret, and I think Lucy left this here last time we were here for someone else to find. I'll put it back. But there are lots of other things as well. So we've got another bit of trilobite, and we've got graptolites on here, and more bits of trilobite. But a nice little silvery graptolite on there as well. Quite a nice little specimen. Now, some of these mudstones are quite tough. They look like they've been baked in some way or silicified. And that could be because they were laid down as part of a sequence with a lot of silica-rich ash above and below, and the silica has just leached through and cemented it. Or it could be that there was an intrusion nearby, an igneous intrusion of something like dolomite, so a sort of lava that would erupt to form these basalts. And that has actually cooked the rock. It's difficult to know in this case which it is, but there's definitely what you call conchoidal fracture. This has been turned into something with a consistency a bit like flint. So I'll just see if we can get inside this one as well. And that is going to be hard work, but inside that is crystals. So that was actually a little fault plane, a fracture plane that has been cemented by quartz crystals. Quite pretty and sparkly, really. One thing that confuses everyone when they start looking for fossils for the first time is colour patterns. And you look at that, that's really rather lovely, isn't it? You've got a nice band of colour which is concentric. It's going all the way around the edge of the rock. And people sometimes think that that must be something fossily because it's colourful. But of course, it's going around the edge because it's actually coming in from the edge towards the centre. This is a very thin fracture plane, thin layer of crystals. The water has been percolating in from the edges and creating chemical reactions which leaves behind particularly iron oxide in bands. So the central part hasn't been weathered, the outer part has been weathered. That's all you're looking at there, weathering. But there are a few other things that we're not quite sure we're looking at here. I do like this one. This is not the mudstone. This is quite interesting. It's got layers of sand in there within layers of mud, and that sand is quite ashy. It's got crystals in there too, I can see. Little square crystals of feldspar, quartz probably, little glinty bits. So this is part of a reworked volcanic ash. And people often ponder whether volcanic ash is igneous or sedimentary. And it really doesn't matter. Quite often it's deposited en masse as a very hot deposit, and that you'd probably call igneous. Other times it lands in the sea and it gets washed around before it's finally deposited. So it is a sedimentary deposited igneous rock. And other times it gets mixed up. So you've got layers of mud and ash in here. It's an ashy siltstone. You don't need to know if it's sedimentary or igneous. Don't worry about it. But what I really like about this is that on the surface there is something quite striking. There's a little curved structure going down there, and there's the rest of it is a sort of slightly lumpy but reasonably flat sheet coming out this way. And that, I think, can only be one thing, because there's a fragment of another one overlying it. But I am pretty certain that that is a bit of trilobite. but a bit of a big trilobite. So that is the corner of the genal spine that goes back from the edge of the side of the head. The centre of the head would be over here somewhere, because this would have to be a Librigina. This would be the flea cheek, the side of the head. So we're looking at a trilobite that would be something like that wide, most likely. That's impressive. Probably would have been this sort of length. And I think there's only one thing that fits the bill. There is something called Basilicus tyrannus, which is a very rare trilobite around here. I've found it once, probably once, in very shallow water deposits at Llandrindod rocks, where you have basically the coastline of the volcano. And it seems to have been a shallow water specialist. But I think this has to be Basilicus tyrannus, which is rather nice to see, and I'll be taking that one back because that is not a common fossil at all. And I'll have to check whether the details of it match, but I can't think of anything else it can be at this stage. And there are, even more rarely, things like lichids, which are large predatory trilobites, but I don't think that's what we're looking at here. Structure doesn't look quite right. So that's definitely one to put to one side. And then I picked this one up because it's not local. And I'm not totally sure where this has come from, but it's really interesting. And it's one of these sort of rocks which you can tell which way up it was. So if you have a look at this in close-up, you can hopefully see there are bands going across it. So lighter and darker bands. I'll try and get my shadow off it. And there are these multiple pale thin laminae going along here, and then it gets darker, and then it gets into sort of lighter grey, and then you've got more of these pale bands. So what you've got here is a slightly odd arrangement of sediment layers, but it's repeated. You've got the coarser, lighter bits here, then the sort of grey massive bit, then thin dark bands, multiple sort of laminae, tiny little thin layers there, and then these, again, the sequence repeats with these pale bands there. And I am saying it that way round because that's the way up it was. This is what we call a turbidite sequence. Now, turbidites are an interesting phenomenon. They were first discovered, really, when they were well, there was an interesting thing, I think it was the 1930s, something like that, I'll check that, where we had undersea cables going across the Atlantic, but there were only about 8 of them. And then there was this odd problem where one of them snapped, the signal just went. And then a little time later, another one snapped. And then the next one, in sequence, going north to south. And these things were a long, long way apart. So something violent was travelling very quickly and snapping cables as it went. And the answer was, it was one of these. A turbidity flow. Basically an underwater landslide. Or that might be overstating it a little. They can start as landslides, but you get these layers of dense fluid with mixed up mud and sand particles, sometimes coarser than that, which is sliding down slope, not down a very steep slope necessarily. It can be quite sort of shallow, but they can be really quite fast and forceful. They can travel at high speed, and they can cut through things like cables that are in the way. And what happens is that the coarser bits fall out first because this is a waning flow. It starts off fast and then it gradually slows down. Sorry, I'm just being distracted by a beetle running around, but I think it's just an Amara. Yeah, one of the ground beetles, never mind me. Yeah, so it starts off with a really fast, high-speed flow, and then the coarser bits settle out first as the flow speed wanes as it goes further and further, or the event just sort of peters out. So it's an event rather than a constant current. And as the flow wanes, the particles get finer and finer, and you end up going from the white to grey to those black laminae, until it gets cut through again by the next event that comes down on top of it. So you know from the sequence of fining upwards that this is a turbidite event. And you tend to get turbidites in very deep water, in the ocean basins, because there you have the continental slope, or equivalents in sedimentary basins, because they're a little bit different, which is giving you a gradient that these things can flow down and then spread out into the ocean basin. And we know that a large chunk of the Silurian in the hills 10-15 miles to the north is made of turbidites. Things like the Aberystwyth grits are the expression of that over on the coast. So probably this came with the glaciers 10-15 miles and has been dropped here. There you go. I think that's most of what we're expected to, or you'd expect to find here, really. One thing I'm not seeing, unlike the quick glance that I had on the beach at Fort William, is bricks, concrete, glass, pottery. I'm not seeing modern sort of human stuff here. It's all natural rocks as far as I can tell, which is amazing because I'd expect the odd bit of concrete in here, but maybe I just didn't recognise it. Oh well, I'll show you a trilobite or two just to keep you happy at the end, but there we go. So that's a Platycalimene pygidium, and oh, that's rather nice. Nematopaigi pygidium inside as well. So yeah, there are trilobites. Quite a lot of trilobites. So, hope you enjoyed that. This was only the second of these Pebble Tales adventures, which I'm hoping to get quite a nice variety of them. I also am planning to do a sort of formal sort of lecture introducing the entire history of the Llandrindod inlier, because, you know, I've spent 30 years of my life working here. I probably ought to tell you about it properly at some point. But are there other bits of this that you'd particularly like to know about, or places that you particularly want us to go? Actually, no, I'm not going to ask that, because you're all going to say the Caribbean, and yes, I'd love to, but until I get 100,000 subscribers or something, that's just not going to happen. In the meantime, though, hopefully we will get to the seaside. It's looking like a really nice summer. In the next couple of weeks, still lots of stuff going on, but after that I'll be able to concentrate quite a lot more on doing videos, and probably even going off to the coast, maybe showing you the fossil forest that we have at Borth. All sorts of ideas. Anyway, thank you for joining me. It's lovely to see you all again, and I will look forward to all your comments. See you again soon. Bye.